Alright, it's time for some worked examples from your assignment of combinations and permutations. I'm going to skip this first part, and you should make sure you know how to get those, figure out how to use the calculator, figure out how to use the online one, whichever one. But yeah, we're going to dive into number 5. And to do number 5, you're going to remember this level of formula. This is from the notes. You're going to try and figure out how many distinguishable permutations, which is rearranging the letters to make new, quote-unquote, new words. You can switch A and the M to make amthematics. In a lot of different ways. So there's a lot of different ways to rearrange the letters. But you have to remember that some of the letters are the same, right? There's 2 M's, and if you switch those places, that does not make a new word. It's the exact same word. And so on top here, we're just going to put the number of words, number of letters, factorial, and then on bottom you got to put all the multiples factorial down there. So on top here, you're going to count how many letters there are. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 letters factorial. Then you have to figure out all your multiples. So there's 2 M's. Let's see, there's 2 A's. Let's see, 2 T's. Only 1 H, only 1 E, only 1 I, 1 Z. Okay, so those are our multiples. So we're going to have 2 factorial times 2 factorial times 2 factorial on bottom there, which you can use your calculator to get the top there and use it to get the bottom. Give me 1 second and I'll figure it out. You figure it out and then we'll have you check. So pause the video and figure it out. Alright, on top there, you should be looking at almost 40 million, and the bottom is 8. And if you divide that top number by the bottom one, you're looking at 4989600. So almost 5 million there. And voila, we figured out that's how many different rearrangements of these letters you can make. So that one's kind of fun, I guess. Let's jump to another one. We got the discriminants are giving a short evening performance. The latest city has 14 songs on it. However, they only have time to perform 8. How many distinct performances can they give? And distinct meaning like the order is going to matter here, right? If they play the last song of the album first and then the first song, that's different than if they played the first song on the album and then the last one. So that's a distinct performance. The order is going to matter. So this gives you a permutation. And so, we got 14 of these songs, and we're trying to pick 8 of them out, and it's going to be a permutation. So it's looking like this. At this point, just use a calculator, either your graphing calculator or the online one, to get 14 permutate 8, and figure that out. So pause the video and do that. Alright, let's have you check. It's looking like 121,080,960 different unique performances you can do out of 8 songs out of 14 possible. That's a lot of different performances, but that's fine. There's a lot of ways you can rearrange numbers, and this is kind of an example of that. Alright, let's move on to another example. Let's jump to number 17. I'm skipping the NCR part, the combination calculation, and just diving into the word problems. Alright, let's jump to 17. Yep. You need 5 new employees and 20 qualified applicants. How many ways can you fill the staff? Well, this one doesn't say like the first employee's getting something special and the 5th one's getting something different. And so that's letting you know this order does not matter. So order does not matter, and that lets you know that this is going to be a combination and not a permutation. Well, there's 20 applicants, and we're going to be choosing 5 of them, so that makes this 20 choose 5. And again, you can use a calculator. Go ahead and plug the numbers in and see how many different ways you can choose 5 people out of 20. Alright, you should have gotten 15,504. So there you go. Yeah, if order doesn't matter, you're going to use combination. If order does matter, use permutation. and you get a slightly different calculation there. Let's go to our last example of these worked ones, and it's going to be number 20. And this one's kind of a challenging one, but I want to see if you can, I want to do it for you so you can kind of see it in progress. So we got a bag, it's got 14 cherry, 15 lime, and 10 grape suckers in it, which is looking like 39 suckers. That'll be important. And we're going to find the probability of picking 3 cherry and 2 grape suckers if 5 are chosen at random. Okay. Well, remember, probabilities is what you want over possibilities. Okay. This one, it doesn't say that it needs to be 3 cherry and then 2 grape. So this one's order does not matter. And so this is going to be a combination, not a permutation. And so yeah, remember, you always need to figure out if it's combination or permutation. Well, the possible ways to pull out 5 suckers out of a group of 39 is going to be 39 combination 5. On the top here, you need to figure out the number of ways to get what you want. Well, the first part is we need 3 of them to be cherry, and there are 14 cherry. And so there's 14, and we're trying to choose 3 of them then. But we also need to get 2 grape suckers. Well, there's 10 grape suckers, and we're going to choose 2 of them. And you're going to be multiplying these together, right? Because you can pick like different combinations of those, and there's just a lot of ways to pick 3 and 2. And so we're going to be timesing those together, and that's going to give you your probability. So go ahead and calculate that. You're going to get some fairly large numbers here. But yeah, let's have you go ahead and calculate those. You can use the online calculator, graphing calculator to get those numbers. All right, let's have you check and see how things went. On the top there, you should get 16,380 different ways of pulling out 3 cherry and 2 grape suckers out of this group. And on the bottom is the possible ways to pull out 5 suckers out of this group, which is 575,757. And if you divide that out, you're looking at a little bit over, well, it's about 2.8%. But yeah, there's your probability right there. Not really high, but it exists. And there you go. So there's a few examples I want to show you just so you can kind of see a few more if you need them. Good luck on finishing up your assignment.